In this video, I'll be going over evaluating expressions for given values of x and some formulas and how that ties into evaluating expressions. But first of all, we're going to talk about what an expression is. It's that sort of thing. You have a variable and you're doing some math to it. You're multiplying it or adding something, maybe you square it. There is no equal sign because that would be an equation. That's not what we're talking about. An equation is two expressions that have been set equal to each other. We're just talking about the expressions for now. And you might get a problem like this on your homework or on your test in math class, where they ask you to evaluate the expression for the given values of x. So they give you some values of x and they give you an expression. And you're just supposed to take those values of x one at a time and substitute them in for the value of x. They use that word a lot. Remember that one. So we just take 1/2 and we, instead of writing x, we write 1/2. Simple as that. And now we just evaluate. 2 times 1/2 is 1. 1 plus 5 is 6. So the answer is 6 for x equals 1/2. Pretty easy, right? All right, let's do x equals 5. 2 times 5 plus 5. 2 times 5 is 10. Plus 5, 15. And x equals -3. 2 times -3 plus 5. 2 times -3, positive 2 times negative. Positive times a negative is a negative. 2 times 3 is 6. 6 plus 5, -1. So answer is 15 for x equals 5 and -1 for x equals -3. Don't really have to write that out, but couldn't hurt. And that's evaluating expressions. That's it. It's that simple. Now, I'm going to go over some formulas. You'll see how that ties in to this in a minute, because I'm going to use that same word, substitute. All right. Say you're given a problem with circles in it. Circle within a circle. And you're told that the radius of the inner circle is 4 inches. And you're told that the distance between the two circles, I know they're not drawn perfectly, but the distance all the way around is 3 inches. And you're given a formula. Formulas are something that is just expressing a relationship between one value and some others. So they say in this formula, we have the area of a circle is equal to pi r squared. And in this problem, they're asking us what the area of the disk is. The disk would be this area between the inner circle and the outer circle. And you're like, well, you didn't give us a formula for the area of a disk. You gave us a formula for the area of a circle. You can use that formula to figure out what the formula is for the area of the disk. So we have this big circle here, right? We'll call it area of the big circle. That's why I use a sub letter, area sub B. And we'll call that pi times r. R is the radius, right? That's what our formula just told us. It's the relationship the area has to the radius. So what is the radius of the big circle? It's not 4 inches. That's the radius of the little circle. It's not 3 inches. Obviously, clearly, because it should be way longer than that. It's actually combining this with that distance. So it should be 3 plus 4, which is 7. And we square it. And what is the area of the little circle? Use a little cursive L to represent the little circle. Well, that's just pi times 4 squared, because a little circle is radius has a radius of 4, so we were given that from the beginning. So we know those. We know the big circle and we know the little circle. Well, how do we get the area of this between them? Well, you simply take the big circle area and you subtract that little circle area and you'll get whatever's left. So area of the disk is area of the big circle minus area of the little circle. And we're just going to substitute that down in there and substitute that right there. So a area of the disk A sub D equals pi times 7 squared minus pi times 4 squared. 7 squared, 49 pi. 4 squared, 16 pi. (49 minus 16). 33 pi. Check my work there. 49 minus 16, 9 minus 6, 3, 4 minus 1 is 3. Yeah. Good to check work. Not done yet, because we've only, we've only told you a numeric value. We need units in there. An area is always in units squared. Same units that we used from the beginning, it's just squared now. Why? Because we squared it in 7 inches squared. Makes sense, right? 14 inches squared. And then we just subtract them. That doesn't bring it back down to, just inches, because that's just inches squared minus inches squared, and units are the same. Just like how we subtracted this and the pi stayed the same. In fact, I should go into that. Why is it when you subtract 49 pi minus 16 pi, we're not left with pi squared or 2 pi or anything? Well, distributive property from the previous video, except in reverse. So we can factor it out. We'll get into factoring later, but just want to explain why that is. You can factor out the pi and kind of work the distributive property backwards. See? And you can subtract 49 and 16, and the pi will stay the same. See? And if you wanted to go back, there's the distributive property, multiply both by pi. Boom. And you get 49 pi minus 16 pi. It's just a quick explanation of combining like terms. And usually your teacher in math class would want you to leave it. Oops. We want you to leave your answer as 33 pi. But if you take a physics class, maybe your teacher might want a more exact answer. So 33 times pi, 103.7, round up, inches squared.